Okay. Coming to the integrate non-exact differential equations. Non-exact differential equations. Where there is another format of finding out an integrating factor, that is already for exactness you will be checking for dou m by dou y and dou n by dou x na. Instead of wasting our effort, if we put it in a formula, I mean if you subtract one from the other and get it to be a function in a single variable after dividing it by n, then you can write the integrating factor to be, the integrating factor can be e power integral f of x dx. Okay, similarly the other way as well. There's a fourth criteria of writing the integrating factor. Let's see one problem and then proceed. Okay, with the fourth integrating factor and so on. Okay, yeah, the example is x minus y into dx minus dy, this is equal to 0. Clearly I can see dou m by dou y, this is equal to minus 1. Dou n by dou x is equal to 0. Clearly I can see both are not matching. At the same time, with the previous videos that I have done on integrating factors 1 and 2, where the function should be homogeneous, or you should be able to write m as y into some function of xy and n as y x into function of xy. I may not able to write it like that as well. So how do I proceed? The best thing is already I've calculated dou m by dou y and dou n by dou x na. First thing, let me subtract one from the other and check if there is anything fruitful. Okay, minus 1 minus 0 would be minus 1 only. And then when I have m in the numerator, first one, when I have m in the numerator, I'll divide it by n. What's n term, guys? N is minus 1, right? So I'll be having this to be 1. Perfect. So what I'll do, integrating factor in this case would be e power integral x dx, which is not 1 dx, I'm sorry. It would give me e power x. Okay. So what I should do with the integrating factor? Multiply the equation with the integrating factor into x minus 1 into dx minus e power x dx. This is equal, dy is equal to 0. I know this would definitely be exact. In case you want, you can check. This is m1. This is n1. Do remember mdx plus ndy. So if there's a negative sign also, that goes to n1 only. Okay. Dou m1 by dou y would be what? Negative. Y derivative is 1 into e power x. Dou n1 by dou x would be what? Minus of e power x derivative is minus of e power x only. Both are equal. It's exact. Okay, so what do? I'll directly integrate. What that is x minus y into e power x dx. Okay. And then in the y part, I mean n part, if there are any terms independent of x, I will take. No terms independent of x. So I'll be taking 0 only. Now integrated x into e power x. Of course, see here, minus y into e power x integration is itself only. Now x into e power x into e power x is as it is, minus x derivative is 1, e power x derivative is e power x only. This is equal to c. I can take out e power x common. Okay, in all the terms, x minus y minus 1 is equal to c. I can write like this or rearrange it in a more beautiful way. Okay, I can as well do one more problem of this type. Of course, this looks very trivial. So let's do one more problem of this type, where 3x square y power 4 plus 2xy dx plus 2x cube y cube minus x squared dy, this is equal to 0. Yeah, powers are not same. So it's not a homogeneous function. Okay. Obviously, because I'm discussing a non-exact, you can have a hint that it is a non-exact differential equation. Anyways, I'll check it. Powers are not same. I cannot take out y and write it as a completely y into some function in xy. I can't write that also. Okay, so the only option that I have is the third integrating factor, which I'll be checking now. Okay, what do I do for it? first thing is, first I'll find dou m by dou y. So what I'll be getting would be 4 3 is 12 x square y cube plus 2x. That would be dou m by dou y. Dou n by dou x would be what? 2 3 is 6x squared y cube minus 2x. Okay. Obviously, both are not equal. It is not exact. It is not exact. Immediately, what I will do, I'll go for finding out. It's not exact differential equation. So immediately I'll be checking for integrating factors to make it exact. Okay. Since first two criteria are not satisfied, I go with dou m by dou y minus dou n by dou x. Let's see what happens. If it doesn't work this way, I'll go with the ulta way. That's it. Okay. So 12x square y cube plus 2x minus 6x square y cube plus 2x. Minus of minus would be plus, right? So, one thing that you ought to remember is, first, if I'm going with dou m by dou y, then denominator will have n. If it is dou n by dou x, then denominator will have n. Okay. So, 12x square y cube minus 6 would be 6x square y cube plus 4x. What is n? Let's see what's n. N is, yeah, 2x cube y square. Okay. 2x cube y square. N is what? Minus x squared is what I have. Okay. I hope I have not done any mistake, right? Minus x square is what I have. Anything is going, anything is common. I can take x common, but then plus and minus sign are irritating me. So plus and minus sign doesn't allow me to go with whatever I wanted to do. So just go with the ulta. What's the ulta? It's the next integrating factor. What's that? It is dou n by dou x minus dou m by dou y. When n is there first, then it will be n. Okay. So if I go with the ulta case, what happens? Just see here. What happens with the ulta case? This is my m. It should have a negative sign. So this goes off. This also goes off. Let me rewrite once again. M will have a negative sign. Okay, dou m by dou y will have a negative sign. This also has a negative sign. This also has a negative sign. And then n will have a positive sign. So plus 6x squared plus 2x. Now both of them gets cancelled off. This value I know. What's m? What's m, guys? Just see here. What's m that I'll be getting would be, I'll just rewrite it. Yeah, this is what the 12x, okay, this is with a minus sign, and then this term is with the, okay, this term has a minus sign. Okay, so that doesn't go off. So I'll be having what? Minus 6x square y cube will be there. Minus 4x will be there. This is not, this doesn't go off. By m is what? 3x square y power 4 plus 2xy. In the numerator, what I can take common, guys? Minus 2 I can take common. So 3x square y minus 2 is what I have in the, plus 2 is what I have in the numerator. Denominator, you see, I will take y common. So 3x square y cube plus 2, yeah, 2x I'll be having. Okay. Yeah. So both of them get cancelled off. It's, see, very difficult, very tedious. But then you should be little careful. Minus 2 by y is what is remaining. So what I will do, integrating factor, the fourth integrating factor is e power integral function of y dy is what I have to take. I have got it to be a function of y. So e power minus integral 2 by y dy is what I'll have. E power minus 2 log y is what I'll have, which is nothing but e power log y power minus 2. Log and e goes off. So it would be 1 by y squared. That would be the integrating factor. So finally, what I'll have the equation to be is 3x squared y power 4 plus 2xy by y squared dx plus 2x cube y cube minus x squared by y square into dy. Of course, this will definitely be exact. Okay, I'm not going for checking it. I'll directly separate the term. Dx 3x square y square plus 2x by y is what I'll have with the dx. I can directly integrate. Now coming to this term, first term is not independent of x, sir. Second term is also not independent of x. Yes, sir. Yes. Second term is also not independent of x. So I have nothing, no contribution from the second term. Only the first term contribution is there. So what happens is 3x cube by 3, y square is a constant. 2x square by 2y plus 0 is equal to c. So accordingly, this would be my answer. 3 goes off, 2 goes off. So I'll be having x cube y square plus x square is equal to c. That's my x square by y is equal to c is my answer. This is how I will do it, guys. All the four integrating factors I have discussed. Okay, let's see one more problem in the next video.